So basic probability concepts. So some of this stuff you have heard before, but some of this stuff kind of gets breezed over when you have this in other classes because it is a lot of vocabulary, and that stuff is maybe not talked about as much because they want to focus on more the math end of it. But again, statistics is one of those where it's really hard to figure out where it should be placed. Is it a math? Is it science? You know, where does it go? So here are 5 main ones. Pretty simple definitions, but we got to make sure that we know what they mean first. So a probability experiment. Well, we've learned experiment earlier this year. Okay? So it's an action through which specific results, maybe it's a count or some kind of measurement of some kind or responses to something is obtained. So that's basically whatever action we take to obtain that. Maybe it's going around and asking people. Maybe it's a online thing. Or maybe we just count M&Ms or something like that. So that would be the action that is taken. An outcome. I mean, you've heard that word before, I'm sure. But in this case, it refers to the result of a single trial, so one time running through a probability experiment. So whatever that happens to be. If you want to find out the colors, again, we'll go to M&Ms, colors in an M&M bag. A single trial there would be counting that bag as a single trial. Okay? And then if we each counted that bag, each one of yours would be considered a single trial, unless we wanted to put them together. Okay? So it's an attempt. What happened? Okay, the outcome. Sample space. This is probably definitely a word that is new to you. It's the set of all possible outcomes. What could have happened? So in that bag of M&Ms, could they have all been red? Could have been. Okay. Could they have all been blue? Maybe. Could they have all been purple? I don't think so. Unless there's different M&Ms now, from what I remember. So an outcome is kind of what happened. Sample space is all the possibilities of what could have happened. So an outcome is just kind of one of those possibilities in the sample space. An event in this setting is a subset of the sample space. So it's not the entire sample space. That's what subset means. And consists of one or more outcomes is an event. And a simple event. An event that consists of a single outcome. It's one thing. Well, let's see if this all makes sense. Decide whether the event is simple or not. Selecting a computer chip from a batch that has been manufactured that day. Do you believe that is simple? Why do you think it's simple? So you're just selecting the one. Okay. So selecting just one computer chip from that batch that was manufactured. You believe that to be simple because it's that specific chip? Yeah, that's good. Because how many outcomes were there to that? Well, you're selecting a chip. There was one outcome. You're going to select a chip. Okay. For 2, rolling at least a 4 on a 6-sided die, assuming they don't all have 4 on it. Okay. Is that simple? No, because how many outcomes are there? At least a 4, so you say 4, 5, and 6 are all possibilities there, correct? They are all possible outcomes. So is that simple? No, because there's more than one outcome for that, correct? Very good. The question was, it says rolling a4 on a 6-sided die, would that have been a simple event? Yes, because basically how many outcomes are going to meet what you wanted? One outcome, correct? Would meet what you wanted, so that would be simple. Okay? Yes. Rolling at least a 1. There's still too many outcomes. Even though, yeah, there's too many outcomes though. Yep. Questions on that? Really look at how many possibilities there are of something happening. Very good questions. Theoretical, sometimes called classical probability. This is the probability you've been doing since you've started doing probability. Okay. This definition seems somewhat long. Used when each outcome in a sample space is equally likely to occur. So each outcome has the same chance of happening. So a 6-sided die is a good one to use there, unless it's been altered. All of the 6 outcomes have the same probability of happening. It's 1 out of 6. The classical probability for an event E is given by, and I'm going to give you a formula here. So this stands for probability of an event, so we call it E, okay, because that's what we called it up here. So if it was event A, if we were going to call it event A, it'd be P of A, right? Or probability of C, whatever you wanted to call it, but we called this event E, and so the probability of E is equal to the number of outcomes in E, but the total number of outcomes in the sample space. Sounds very complicated. P stands for probability. And a lot of times when I've had, well, we'll wait on that. All right. You roll a 6-sided number cube. Determine the probability of the following events. Again, we just went with something that you probably were familiar with. And yeah, we are supposed to call it a number cube instead of a die, because apparently gambling is assumed when we use the word die versus number cube. I think you all know what it is, so I think the chance of gambling is the same no matter what I call it. Yeah, I think I probably did. Determine the probability of the following event. Event A. So here we go. We're just calling it that. This is a name for it. Rolling a 3. Well, how many outcomes are there? No, outcomes of rolling a 3. How many ways can I have that happen? If I only roll it once, how many outcomes are there? 1 in that event, right? That's how many times, basically, I'll get what I want. Look at it that way, right? Over, what is the sample space? You could roll the sample space is a 1, a 2, a 3, a 4, a 5, or a 6, correct? Do you agree that's what the sample space is in this problem, right? And sometimes you might see sample space written a little different, so let's make sure that the notation doesn't get you. they'll say the sample space and they'll put brackets around like that, braces like that. And then sometimes they'll say, oh, the outcome, well, what is my outcome here is, right? Now they're saying the outcome is 3, not that's how many there are, right? So how many outcomes meet what I want here? How many outcomes are in that event? Only 1 out of the 6, okay? So you see how you're really counting how many are in the outcome and how many are in the sample space? Not necessarily what it is. So don't put necessarily the 3 on top here, all right? So it's 1 out of 6. Do you agree with that probability? Yeah. Now does that mean if you rolled the die 6 times, the 3 would happen once? There's no guarantee of that, correct? That's what would probably happen, hence probability. Okay. How about rolling a 7? So our outcome that I want is still a 7. But what's the, ooh, that's those are nice. What is the problem with that? It's not in the, use the vocabulary, it's not in the sample space. So how many times is this going to happen out of that sample space? 0. So it's 0 out of the 6, correct? And so 0 over 6 ends up being just 0. Ooh, that's a good one. How about rolling a number less than 5? Our outcome, what would be in that set? This is just set notation, all these braces and stuff. So 1, 2, 3. That one's really bad, but anyway. 1, 2, 3, 4. Again, so am I going to add those up? And what is that, 10 if I add those up? No. You want to find out how many of them there are. And how many are in there? There are 4 over a total sample space of 6. So we're looking at 2 out of 3. Okay. Again, that doesn't mean if I rolled the die 3 times, I would automatically get 2 of them that would be less than 5. But that's probably what would happen. Okay. Let's face it, you could roll it 20 times and not have it happen once. Okay. Is it very probable? No. But is it possible? See, those are 2 really big words to keep straight in your head. Possible, improbable. Okay. Questions? Because a lot of times we kind of call this success over total is a lot of the ways that I refer to this, correct? Number of ways to be successful over the number of total ways something could happen, right? So statistical, sometimes called empirical probability. I'm not a big fan of all the different names they have for them, but I want to make sure that if someone uses a different one that you know it's a possibility, okay? This is not theoretical, okay? There was theory behind the die, right? That there were 6 options and I wanted this to happen. This is much more observational, based on what you've seen. Yeah, or heard. Yeah. Any observation. Seen, heard. I suppose mouth would be there. It's an observation. Or like that one that Mr. Brooks brings around for his classes where you taste the paper, right? That's obviously an observation of some kind. And the one tastes like anise, I believe, like that black licorice taste. Right? The one for some people it just tastes like paper. So again, we'll call the event E for this, so it's P of E is kind of what you're going to start with. Frequency, oh, there's a word that we've seen already this year, of event E. So how many times did what I want to have happen? Over, oh, how many times did I look or taste or listen, right? Now, it's sometimes very hard for people to come up with a statistical or empirical probability. But really, if you think of anything in business, that's what they do. They watch what has happened, and that's how they come up with their probabilities. Okay? And one thing, one particular place that really pays attention to people your age are insurance companies, especially car insurance companies. To determine their rates, they look at how frequently You get into accidents. And they also look at male versus female. Okay? When I was in high school, females paid way less for car insurance than males did because they noticed that more males got in accidents back then. Congratulations, females, you're catching up. The tides have turned. Of course, they didn't lower the males, they just raised the females' rates because they've realized that that is not accurate anymore. Okay. So here we go. An insurance company determines that every 100 claims, 4 of them are fraudulent, meaning fake. Okay. What is the probability that the next claim the company processes is fraudulent? So you see how this is based on some observation that they made, correct? This is not a die or playing cards or something that we know there is set probability there. This is they've watched, okay? And so what would that probability be? Really, it would be 4 out of 100, right? Which we could change to 1 out of 25. Or some people don't like probability as that fractions, because what's another way you could write probability? Some like percentages, or some just like decimals, right? So this would be what, about 0.04 in decimal form, or you could say 4%, right? Any of those, it depends on how you're told to write it, or how you prefer to write it. If we are going to use it in a calculation, though, probably stay away from 4%, right? If we're going to use it in a calculation, use the either decimal or fraction representation. Okay? So are you very clear on the difference between either you can call it empirical or statistical, and then the other one is classical or theoretical? The biggest difference between the two? This is just based on what people have seen or observed in some way. Subjective probability. This is basically just a guess. An educated one, hopefully. For example, I would make a guess that the Packers this year, based on their performances in their games, the probability that they finish above 500 is about 50-50. That's my educated guess. Is it very possible that one of you would give a different educated guess on that same question? Yes. But I'm going with intuition or some kind of estimates based on what I've seen. Okay? So that's subjective. Okay, classify each statement as an example of classical, empirical, or subjective. Again, classical is also known as, which one? Classical, and which is also known as theoretical. Empirical is also known as statistical, and subjective is just known as subjective. So explain. So the probability of your phone ringing during dinner is 0.5, or in other words, 50%. What do you believe that would come out to be? Could it be either one? Because the two answers that I heard were empirical and subjective. I'm glad the one I didn't hear was classical or theoretical. So how could you say that that's subjective? Okay, it's a logical guess. Okay, so how could somebody make it empirical? Yeah, if you keep track. If you actually sit there and next to the phone you have, yes, they called. No, they didn't. Yes, somebody called. No, they didn't. Well, then would you know? You would have something to base that off of, wouldn't you? So you see, that's why there's explain there. It depends on how you interpret that question, correct? But more than likely, I would be more subjective on that because I'm not going to take the time to tally that, but you could. You could do that. Okay. I think better is how many actually answer it during dinner would maybe be a better. Yeah, not too many, right? That would be, okay. Number 2, so yeah, either empirical or subjective as long as you give your reason why on number 1. Number 2, the probability that a voter chosen at random will vote Republican is 0.45. You believe that's statistical, otherwise known as empirical? And why do you believe that? More than likely it's based on something, correct? More than likely it is based on some kind of poll that was taken, okay? And so that would be kind of those observations that were made. Is that necessarily theoretical? No. Okay, that's not where we're going with there. You had to observe something to figure that out. Given a six-sided die, you can tell that there's 6 options, okay? So could you make that a subjective answer for number 2? Yeah, I'd say it's not as easy as number 1, but you could call that one subjective if you give the right reason. 3, the probability of winning a 100-ticket raffle with 1 ticket. Oh, that was a 1,000-ticket raffle, so hopefully you fixed that. Is it fixed on yours? Okay, good. So the probability of winning a 1,000-ticket raffle with 1 ticket is 1 out of 1,000. That's classical, right? I mean, that's just what it is. I mean, boom. There's no observations needed there. Okay? Now, if it was me that had the 1 ticket, I'm not so sure that classical follows through on that. Okay? If there was one time I had a lot of tickets in one and won nothing. Yeah. So yeah, I'm not real good with classical. I need some kind of help. Okay? And here's something big, law of large numbers. As an experiment is repeated over and over, the empirical probability of an event approaches the theoretical. Do you agree with that? Because which one's which? Empirical is the one you observe. Theoretical is, yeah, based on that. So again, flipping a coin perhaps. It is supposed to be 50-50, right? 50-50 shot for heads and tails. Okay, so as I keep flipping that coin, is it possible that I would get 10 in a row that were heads? That is possible, correct? Probable? Not very, but it's possible. But they're saying as I did that maybe 1,000, 2,000 times, would the number start going towards 50-50? My observations, would it start tending towards 50-50? So is the empirical starting to lean towards theoretical? It is. So that's the law of large numbers, that the two should be very close once you get up in numbers. And that does mean fairly large, though. That doesn't mean 10 or 20. Okay, that means a lot. Okay? Yeah, not 4. Okay? And I think this is the last one, right? The complement of an event. We've seen the word complement before, as in complementary. Okay? Means somewhat slightly different here, but this can save you so much time when finding probabilities, so make sure that you know this. Because what's the total for probabilities? If I added them all up for some kind of event, what should be the percentage or the number total? The percentage total should be 100%, correct? And decimal total should be 1. So the complement is basically the set of all outcomes in a sample space that are not included in the event, or basically what's the probability that it doesn't happen. So isn't that everything else? If you know the probability of something happening is 40%, the probability it doesn't happen is 60%, right? So it's really, you could kind of, and it is notated by like E prime. Okay? Is what that little note is there. So again, it is kind of, you could look at it as 1 minus whatever I got. Okay, or 100% minus whatever the percent is. Hugely helpful and can save you time. So again, maybe we'll just say that one again. If the probability of event E, so let's say probability of E is 0.40, the probability of E prime has to be 0.60, right? Because these two added together better be 1 or 100%, right? Okay. And that just helps you with notation a little bit. Okay. And again, I could give you any beginning number. Okay. Questions? Good? All right.